11.4 is circumference and arc length. We've already done arc measure, which was in degrees. Okay, your arc length is going to be in some label, like a linear label, like inches, centimeters, meters, feet, yards, something like that. I do understand that most of you have probably already done some circumference things. What is circumference of a circle? It's around it, right? Very similar to the perimeter of other shapes, right? So if you wanted to, you could think of circumference as perimeter of a circle, right? That's what it is. It's the distance around your circle. Okay, that's your first theorem. Okay, so luckily you get to put it on your theorem sheet. I would suggest that you know circumference of a circle and not have to look it up on your theorem sheet. Okay, but we have circumference of a circle. Anybody know it off the top of their head? Close. It's not 2 pi r squared, it's just 2 pi r. That squared is actually with area, so don't get those confused. Bless you. Your circumference is 2 pi r. Now some people, I don't like this, some people like to think of it as pi times diameter. I personally don't like that, but it's kind of personal preference, really. Because R stands for, D stands for, 2 times the radius is the diameter. Same thing, right? Just written in different form. Okay? So, and it's not too hard to multiply or divide by 2 to get your radius or diameter, depending which way you're going. So whichever of those you choose to use is fine by me. Just understand they're the exact same thing. Okay, more often than not, you're probably going to be given the radius, which is why more commonly you see this one, because you're more often given the radius than you are the diameter. Okay. All right, I do have 2 examples I want to roll through real quick here. It seems really easy, except I'm going to change a couple things because we don't like to round our answers, right? We like to get exact answers. Everybody agree with that? Like when we do radicals, we don't want decimals. We want exact answers. So that's a little bit different than what the book has here. So we want to find the circumference of a circle with a radius. Oop, that's not a circle. With a radius of 9 inches. We want to find the circumference. Okay, so again, we know circumference is 2 pi r, correct? So in this case, it's 2 pi 9. What operation is happening? Oh, it's all multiplication, right? If it's all multiplication, does it matter what order I do it in? No. So, could I just take 2 times 9 and I would get, this is what I want your answer to be. Okay, that is called leaving it in terms of pi. Why would I do that? It's not rounded. Is that what you're going to say, Taylor? Yeah, so you don't have a big decimal number. Okay, it's not rounded. This is an exact answer. It cannot get any more exact than this. If you were to actually take 18 times pi in your calculator, you're going to get a decimal, and then you're going to round it, right? So from there, it's no longer an exact answer, because you've rounded it. We want to keep those as exact answers. Questions on that? I think we can do that. Now, you do have to understand your book is probably going to have decimals, and I'll get to that in a little bit. Now, let's say that this was 9.1 inches, because this was a question in first period. Well, then, instead of 18, this would be 18.2 pi. The catch here is, did I start with a decimal? Am I okay to end in a decimal then? Okay. The way I explained this last period is this is kind of being like halfway in, halfway out. It's halfway rounded, it's halfway exact. Okay, we can't make up our mind. If this is the case, get it all as a decimal. Okay, we don't want to be halfway in, halfway out. Okay, we want to make up our minds. Okay, we don't want to be swaying on our decisions. We want to have an exact decision and know if this is a decimal, let's go ahead and get a decimal. So in this case, I would do 18.2. Don't use 3.14. Your book is going to say use 3.14. I don't want you to do that. Use the pi button. So locate the pi button on your calculator right now. That's what I want you to use. Okay? I want you to type it just like this. Don't put 18.2 times 3.14. Okay, because then you've already rounded. 18.2 times pi. What did I get, Seth? 0.18, right? Or 2. It's either 1/8 or 0.2 inches. Okay. You guys get what I'm saying with the halfway in, halfway out thing? Okay, if there's a decimal, make it a decimal. If there's not a decimal, don't let there be a decimal.
But if it really was 9.1 inches, and the diameter really would be 9 or 18.2.
The diameter would be 18.2,
Yeah.
yes.
So
The diameter would be.
It's not really like rounded.
No,
It
but it's a decimal. And we try not to do a decimal with like pi or like the square root of 2. If you were to get an answer like 3.7 square roots of 2, have we ever wrote an answer like that? No, it's always a whole number and then the square root of 2. So we try to avoid exact with decimals. You know what I mean? I get what you're saying. I do. But we don't want a decimal with something else like this. Because these are irrational numbers. It means they go on forever. Okay, so if possible, we don't want to actually multiply them. We want to leave them as their symbol. But if there's a decimal, we go ahead and just write it all as a decimal. Okay? With us, Ryan? Okay. Does that make sense to everybody? If you have a decimal, you can get a decimal. If not, we're going to try to avoid it. Okay, we're going to get exact answers. Now, the other thing that might happen is you might have a circle, and they actually tell you that the circumference is 52 inches. They want to know what's the radius. What do you think you have to do here, Jacob? So you're still using your circumference, right? They just happen to tell you what your final answer is. Okay, before I go any further, did we start with any decimals? Okay, so we're going to avoid getting any decimals here. What do I have to do to get r by itself, Royal? Okay, I do have to divide by what? This is the catchy part for some people. I want r by itself, so I don't want to divide by r. I have to divide by 2 pi. Okay, so I divide by 2 pi. That cancels, right? On this side, I divide by 2 pi. So I actually have r equals 52 over 2 pi. Can I reduce that? What can come out of the top and the bottom? A 2. So I divide that by 2, I get? I divide that by 2, I get? 1. So my radius is actually 26 over pi. Label? Inches. Hey, you're going to be able to do a lot of this in your head probably if you're leaving it in terms of pi. As soon as you hit that pi button on your calculator, your mental math aspect is probably gone, right? Because you're going to get some funky decimals. Okay, but a lot of this you should be able to do almost in your head. or by hand anyways, excuse me, without a calculator. Okay. The next thing and the biggest portion of what we're talking about in this chapter, or in this section, excuse me, is arc length. And what we come to is called the arc length corollary. Go ahead and put this on your theorem sheet. Okay? It's not technically a theorem, but it's a corollary, which is an addition to a theorem. Notice we're finding arc length. In the past we found arc measure. Today we're finding arc length. Okay, so I have circle P with points A and B on the circle. Now when I find arc length, I'm finding how long is it from A to B, right? Is that, or isn't that, just a chunk of the circumference? Isn't that just a portion of my circumference? Yeah, it's like that little piece right there of my whole circumference. Okay, so we're trying to find basically a fraction of our circumference. Okay? Our theorem tells us that I'm going to set up a proportion. There's two ways you can set this up. I don't like the second way, so I'm not even going to talk about it. I'm going to do it in a proportion. Once I have a proportion, how do you solve a proportion? You cross multiply. See? So we all know that. So that's why I'm going to set it up as a proportion. And it gives us an easier way to solve for other things too, which we'll get to in a little bit. Okay, but it starts out as arc length over 2 pi r, which is actually just what? It's actually just circumference. Okay, so it's the arc length over the circumference equals the measure of the arc, which in this case happens to be AB. I'm not going to put AB there, but just so you know, it's going to be whatever arc you're trying to find. So it's the arc length over the circumference, or 2 pi r, equals the measure of the arc, which is in degrees, right, over 360 degrees. So the only number that's always there is that 360 degrees. The other ones might or might not be there. So there's actually a lot of different things that could happen here. We could find the arc length if they gave us the radius and the measure of the arc. We could solve for arc length. If they gave us the arc length and the measure of the arc, we could solve for radius. If they gave us the arc length and the radius, we could solve for the measure of the arc. Okay, so there's a lot of different ways or things that we could solve for out of this theorem. The first two examples we're going to do, we're just going to solve for arc length. So I have my circle, and I have an arc down here. This central angle is 60 degrees. It might be kind of hard to read, but it's 60 degrees, and this is 16 inches. Go ahead and put some letters in here. Yes, sir. Gonna set it up? Give me 1 second. Let's everybody get this drawn out real quick. All right, Jacob, go ahead. You can do it that way if you wanted, but so in my proportion, what is always top left? Arc length. Do I know that? No, that's actually what I'm trying to find. I want to find the length of JK. So if that's what I'm trying to find, I'm going to put in X over, bottom left is always 2 pi r, which is 2 pi 16, which is actually 32 pi, equals, now I want the measure of my arc. Well, I thought that was the measure of my angle. But they're the same. Remember, your central angle is equal to the measure of your arc. So I have 60 over 360. It will make it significantly easier for you if you go ahead and reduce this. Okay, so immediately you should see that you can drop off those zeros. 6 over 36 is 1/6. So I actually have 1/6 equals x over 32 pi. Okay. Again, did I start with any decimals? No, I'm going to try to leave it as an exact answer then. I'm going to try not to get a decimal. Struggling. I don't know what the deal is. So how do I solve this? I cross multiply. 32 pi times 1 is 32 pi. 6 times x is 6x. And then I do what, Vincent? Get x by itself. Solve for x here for me. How do I divide by 6? Yep. So I divide there. Now, can I take this and divide evenly? No, but can I reduce it? Hey, what can I take out of 32 and 6? A 2. So 32 divided by 2 is? So I have 16 pi on top. On the bottom, I take 6 divided by 2 and get 3. What did I just find? I found the arc length. So what's my label? Inches. My arc length is 16 pi over 3 inches. Now this is where I want you to be careful. Is your book going to give you that answer? Probably not. So in the back of the book, how do you check and see if you're right? Yeah, just plug it into your calculator. So you take 16 pi, enter, divided by 3, and you get 16.76, which is exactly what I got or what the book got. Okay? So you might, to check your answers in the back, you might have to quick plug that in a calculator. Okay, but we're going to try to leave our answers in terms of pi. Leave your answers in terms of pi. And some of your directions are going to specifically tell you to leave your answers in terms of pi. Okay, but we're going to try doing that all the time. Okay. One more real quick. I have this, center, 100 degrees, 6.21 centimeters. Now looking at this, immediately, hopefully we recognize that that might be a decimal answer, right? Okay. So when I go ahead and set this up, Carson, how do I do that? I'm finding length again, sorry. Okay, so we can go ahead and double that 6.21 to 12.42, right? Why am I not taking it times pi right now? So if I take it by pi right now, then I'm going to take a rounded answer. I'm going to cross multiply it. and then I'm going to divide it, right? So the more you use that number, the more off it becomes. Okay, so we want to try to avoid using that pi right now. Equals, sorry Carson, keep going. Okay, can I reduce that? Zeros go. 10 over 36 is the same as 5 over what? 18, good. Okay, so now I can go ahead and cross multiply. 18 times x is 18x. 5 times 12.42. 62.1 pi. So now what do I do? Divide by 18. What'd you get, Taylor? 3.45. You must have done something wrong. Did you take it times pi? Did you take 62.1 times pi and then divide it by 18? That's your problem. Okay. So what did we get, Carson? 10.84 is fine. Length, so my label is centimeters in this case. Okay, so just an example. If you have a decimal, let's just go ahead and put the whole thing as a decimal. Okay. Alright, now, these next examples are like what I talked about up when I wrote the theorem. You can find other measurements out of this. It all depends on what you're given. So, if they give you a circle, like so, let's say this is AB. They tell me that this is 8 inches and this is 16.72 inches. Sorry, 7/6. They want to know what is the measure of arc AB. So now I'm finding something a little bit different. When I set up this proportion, Taylor Arnett, what goes in the top left? Is it? Yeah, it's not x anymore, is it? Because I already know my arc length. It's 16.76 inches. The measure of arc AB. The measure, the degrees. Okay, so I have 16.76 over 2 pi r, which is 16 pi, equals, good, x, because I don't know my measure, over 360. There's not really any reducing you can do here, so we just go ahead and cross multiply. What is 360 times 16.76? Equals, close, 16 pi x. So then Taylor Hart, how do I solve for x? Good, divide by 16 pi. How many people got 1,184.7? Yeah? A lot of us, right? So then why is the correct answer this? So, what I would tell you, I wouldn't do it first, Royal. You could, Royal said do the pi first. Okay, you could do that. What I would do is I would just use parentheses around this. If you don't, then it's going to do this. If you just type it in your calculator, divided by 16 pi, there's a multiplication in between 16 and pi, right? Okay, so I'm going to go ahead and write that there. Your calculator understands the order of operations. So it knows that your division and multiplication are on the same level of your order of operations. So what it does is it takes 6033.6, it divides it by 16, and then it takes that answer times pi. That's not what we want, right? We want 6033.6 divided by whatever 16 pi equals. So if you put parentheses around your 16 pi, that would work. If you took 6033.6 divided by 16 divided by pi, that would work. Okay, but what I would suggest to you is anytime you have a number like this, where it's 16 pi, just put parentheses around it. Because then you know that it's being grouped together. So like even up here, it didn't actually matter. Like when you type this in, it didn't matter. But when I type it in my calculator, I still put parentheses around it, just out of habit. Because it's just a good habit to have. Like right here, if you were to solve that out, I'd put parentheses around that. Up here, I'd put parentheses around the 2 pi. Okay? You guys get what I'm saying? Just be careful. Understand that your calculator knows order of operations just like you do. Okay? What would my label be here since I found a measure? Degrees on this one. Pay close attention to what you're finding. We found a measure of an arc. That's going to be in degrees. Yes, sir? Sorry? Well, see, it asks for the measure of the arc, though. So if you wanted to be specific, you'd say the measure of arc AB equals 120.03 degrees. It asked for the arc. It didn't ask for a variable. It asked for the arc measure. Okay? I know we wrote it as x equals, but that's what the arc equals. Okay? Okay, we got 2 examples left. One basically like that one. They give me a circle. They give me a arc measure of 45 degrees. It's actually a central angle measure, but we know they're the same. And then they tell me this is 10.2 centimeters. Okay, again, you notice a decimal, so there's a possibility that we have a decimal as our answer. They want to know this time, what is the circumference of the circle? Okay. So Jacob, top left, would go 10.2. Okay, so this is where you have options. You could put 2 pi r. Okay. When you solve this out, you would solve for the radius. Once you know the radius, you can find circumference, right? That's one option. Option number 2 is you know what is 2 pi r. That is circumference, isn't it? So if I just put x right here, if I solve this out and solve for x, what did I find? I found the circumference. Okay, so those are your options. You do have options there. 2 different routes that you could take. I'm going to go this route because it's actually easier. Equals anybody know what that reduces to? 1/8, which is the same thing. Because if that were 90 over 360, 90 is a fourth of 360, right? Well, half of 90 is 45, so that's going to be 1/8. So that's actually 1/8. Cross multiply x times 1 is x. 8 times 10.2 is 81.6. What's my label? Centimeters. I found circumference now, right? Okay. Questions so far? It's all the same proportion, right? The question is, what do you know? What are you solving for? All right, the last thing I want to take a look at what's that look like? I think it looks like a pill. Okay, but it is a track. I drew one earlier that looked more like a surfboard. It was bad. A Band-Aid? Alright, I see it. Or what? A hoverboard? Alright, I see that too. Okay, but this is a track. For what we're using for, it's a track. What we're going to do is we're going to find the difference in the length of lane 1. We'll say the lane 1's there in black. And the length of lane 2. That was bad at the end. A little bit better. Okay. Those of you who are in track, and probably those of you who are not, know that the lanes are longer the further out they go. Okay. So what they give us for information is that the radius from that point to the first lane is 29 meters. The radius from that point to the second lane, I think, is 30.25 meters. Okay, and then the other information they give us is that the distance from where they both straighten out to where they both start to curve again is 108.9 meters. Okay. And again, that straightaway is the same on each lane. Okay, they both start going straight at the same point and the same distance. Like a 100-meter dash. Okay, they don't stagger at all for 100 meters. Okay, so we want to find the difference in the length, which would have to do with arc length, right? Because we need to find this arc length. You guys agree with that? Okay. How many straightaways are there? 2, right? In just lane 1, there's 2. So I have 2 distances of 108.9, correct? Everybody agree with that? Okay. Then I have to add to that this distance and this distance, right? Don't I have to add both of those? Okay. Now, it does what, Carson? Didn't you just say it does something? It makes a circle. Okay, so I did have people in the other classes say, okay, well, we can find the arc length because we just did, right? We just found a whole bunch of arc lengths. We could find the arc length, and then I could double it, and then I would have the total, right? Which is true. Okay, I agree with them. But those 2 parts together, mine might not, but they actually make a full circle, right? Does the radius change? No. So how do you find the distance around a full circle? circumference. So I want to add 2 pi r, which is, for lane 1, 29. And then you should be able to plug that straight into your calculator, actually. So you have 2 times 108.9 plus 2 pi times 29. And what do I get? It's the distance around lane 1. .01 meters. Okay. Did everybody get that? What did you get, Seth? It might just have to do with how it was typed in. Can I check real quick?
584 times 2 plus 218. I was doing a whole bunch of weird stuff.
So what I would tell you, type it in just like this. Yep. Go 2. You don't even need these parentheses because it's going to do your order of operations. So it's going to multiply these two numbers first, and it's going to multiply these 3, and then it's going to add them together because your calculator knows order of operations. So that one you can type straight in. Got it? Okay. Now on lane 2, same ideas apply, right? Do I still have my 2 straightaways of 108.9? Yeah, I still have that. But instead of 2 pi 29, now I have 2 pi 30.25. Otherwise, it's all the same, right? What is it? So a pretty significant difference between lane 1 and 2, right? Which those of you who do track, how do they compensate for that? They stagger the starts. Okay? So like if you were running a 400 meter dash, do they call them dashes or is it 400? They just call it a 400? I think it's a dash for the 400. So lane 1 starts right here, but lane 8 starts like, I don't know if they start this far up for a 400, and I think that might be like an 800. Okay, but you know what I mean, right? They stagger these starts around. So lane 1, lane 2, lane 3, lane 4, lane 5, lane 6, lane 7, lane 8. They stagger them all the way around. That way they can compensate for this change of distance that they're running. Okay. So in this case, they would have to basically put lane 2 7.86 meters further forward, right?
Their tracks kind of messed up though.
Well, that's because I drew it.
Well, no, like they're 100s or. Yeah, and it was 400.
Well, know that when you run the 100, you don't run from the start of the curve to the end of the curve. You start up here. Look at it when you get to track practice. You don't start right at the curve. Okay? What I want you guys to do for me for tomorrow, please, is give these problems a try. It's page 686, 1 through 14. Please give those a try.